Shanghai Microelectronics Equipment, or SMEE, is China's ambitious project to replace ASML. The company has been around for a while, and they have received a lot of attention and cheerleading in the Chinese media. But recent high-profile export bans to China have brought them special focus. In this video, we're going to take a closer look at this undercovered company, what they have been able to produce, and how they are doing so far. I lean pretty heavily on a deep dive profile by Equal Ocean about SMEE. I highly recommend it for additional detail if you are curious to learn more about this company and its future challenges. For everything else, I relied almost entirely on China-based sources. Keep that in mind, please, before you start screaming at me in the comments. China's first lithography machine was created in 1977, the GK3. 2 years later, it evolved into the JKG3, the first domestically created lithography machine for large-scale commercial production. The GK4 prototype came a year later in 1978. It was a contact lithography machine able to print chips on 75mm wafers. Contact lithography is where the photomask is in direct contact with a photoresist-coated substrate. It has its uses, but is also known for high defect rates. The United States invented and commercialized contact lithography in the 1950s, so at this point China was 2 decades behind. After this, the next stage in the commercial tech tree would be the proximity aligner. This introduces a gap between the mask and the substrate. After that would be the step and scan device, or stepper. The Chinese would try to develop these two simultaneously. In 1981, the Institute of Semiconductors of the Chinese Academy of Sciences successfully developed 2 proximity aligner prototypes. In 1985, after 6 years of work, the 45th Institute of the Ministry of Mechanical and Electrical Engineering developed a stepper of their own. This machine, quote-unquote, inspired by the 4800 DSW, made by US-based GCA, printed designs using the 436nm G-line. In 2000, China began research on machines using argon fluoride lasers on the 193nm wavelength. Since the West began shipping its first such devices in 1990, there has thus remained a large technology gap. The government apparently must have thought a change of direction was needed. SMEE was founded a few years later in March 2002. China's 12th five-year plan, which covers the 2011 to 2015 period, included 16 major national special projects. Lithography was ranked the second highest, which is why it would be called the 02 Special Project. The special project had multiple goals. The top focus was to develop manufacturing equipment capable of producing 22 to 45nm process chips. Other goals include carrying out forward research on 14 to 22nm processes, work on 65 to 90nm special processes, capture at least 10% of the domestic lithography market, and attempt to open up the international market. SMEE was thus deemed the country's national champion for turning these goals into reality. The company's first office was in the Shanghai Zhangjiang High-Tech Park in the Pudong district of Shanghai. The company's semiconductor-related neighbors included SMIC, Grace Semiconductor, and Spreadtrum. The company's founding general manager and chairman was He Rongming. He worked hard at the task, saying in an interview, "I really have nothing worth writing about. I can't tell the wonderful stories you want to hear. I just did one thing in more than 10 years. Except for business trips, I go out at 7 a.m. and go home at 10 p.m. Saturdays are guaranteed no rest, and Sundays are not guaranteed. This was the whole of my life for more than 10 years. Over the 2 decades of its existence, SMEE has developed its products on the back of extensive R&D. As of 2019, the company has filed for over 3,000 patents and received 1,600 of them. Nearly 700 of those patents are in foreign countries, which is notable. To support its journey, the company has received extensive support from both the Chinese local and central governments. SMEE's single biggest owner, with 32% of the shares, is the Shanghai SASAC, the commission overseeing all of the city's corporate assets. But there are a few other private shareholders, including some VCs. Lithography technology is a very protected space, dominated by 3 companies with government backing. SMEE encountered import restrictions almost from the very start. For instance, high-level optics from Carl Zeiss of Germany. None of their best stuff could be imported into China. Thus, for its first products, the company decided to target a portion of the lithography market where the competition is less intense and the requirements less strict: lithography for advanced packaging processes. Advanced packaging describes a set of processes for placing a chip in its protective casing and connecting them to the outside world. It is an essential and previously unheralded part of the semiconductor manufacturing process. Trends like chiplets have unlocked great performance advances and stimulated the need for advanced packaging technology. The idea was that the company can cut its teeth in back-end lithography and then work its way up from there to front-end lithography, where the big boys play. The strategy has shown traction. SMEE products are now good enough to hold 80% of the domestic market in back-end lithography, corresponding to 40% of the global market. In 2019, they shipped over 50 units. Their major back-end customers include Changjiang Electric Group, Taiwan-based ASE Group, and Tongfu Microelectronics. After that, SMEE began expanding into lithography tools for other niche semiconductor products: power devices, microelectromechanical systems, or MEMS, and LEDs. LEDs are probably the most promising market of these. Finally, the company started developing for the front end with the intention of selling those to companies like Yangtze Memory and SMIC. More likely Yangtze, since SMIC is pretty locked in with ASML. Unlike its Japanese competitors Canon and Nikon, SMEE is built in the ASML model. They want to be the final system integrator for the lithography tool's various parts. The company works with a variety of suppliers to help build and put together a new lithography machine. At the heart of it, the core factors for a machine's success include 1. High precision optics, 2. The light source, 3. High precision mechanics, and 4. Software. For the light source, ASML relies on companies like Kymer. For its optics, they rely on a joint venture with Carl Zeiss. These are so important to the whole machine that ASML either holds significant equity share in the corporate entity or owns it outright. EqualOcean identifies SMEE's Carl Zeiss to be two companies: Changchun Up Optotech and Beijing Guowang Technology Company. But they also note that Changchun is no longer associated with the SMEE. So that leaves Beijing Guowang. They are in the midst of building an optics manufacturing factory, so they likely won't be able to supply an immersion-ready optical system en masse until that is done. SMEE's Kymer would be Beijing RS Laser Optoelectronics Technology. RS Laser's product is underpowered compared to what ASML uses for their immersion systems. I have never heard of any of these companies and presume them to be staked-back entities spun off from universities or research laboratories. Something that is not really a problem for ASML but has relevancy for SMEE has to do with the requirement for domestic suppliers. There remains a number of core technologies that still have to either be imported or purchased from foreign companies. For instance, photomasks, the plates that hold the chip pattern to be printed onto the wafer. The vast majority of these are made by Japanese companies, Toppan Printing and Dai Nippon Printing. Though EqualOcean again notes that a Chinese native company, Jiangsu Nata Optoelectronic Material Company Limited, or just NATA, has created a photomask that successfully works in an ASML immersion system. So maybe those can get replaced in due time. But that is just one example. Ball bearings from Sweden, valves from France, and grading alignment systems from the United States, none of these are made in China, and without them, it is hard to ship a commercial-grade working machine. I do not want to give the impression that once this one thing is done, then everything else is all good. As of this writing in August 2021, SMEE systems are for the 90nm, 110nm, and 280nm processes. As I mentioned earlier, these are specialized systems for back-end lithography, LED, MEMS, and power devices. Lithography systems are generally grouped by their laser light source. You have I-line machines, krypton fluoride laser machines, argon fluoride laser machines, argon fluoride immersion laser machines, and finally EUV machines. The majority of SMEE systems use I-line and krypton fluoride lasers. But their most advanced system, the SSA 600/20 scanner for front-end manufacturing at the 90nm node, uses an argon fluoride laser, which I will shorten to ARF because it sounds cute. A prototype of this product, the 600/10, was first profiled in 2011. It had a field size of 22mm by 32mm and can process about 50 wafers an hour. Comparable Canon and Nikon machines can do up to 5 times that number. That was over 10 years ago. Since then, it seems like they made just one more iteration, from the 600/10 to the 600/20, which as of 2019 is estimated to not be selling in relevant quantities. The company's recent sales are still in the way outdated eye-line lithography machines, which I do not think bodes well. The most prominent piece of news about this company's future pipeline is that they have an argon fluoride immersion system, which I will hereby refer to as an ARFI system because that is also cute. This machine is said to be capable of the 28nm process node. This 28nm tool is right now a prototype. China has in general been pretty good at building prototypes, lagging the leading edge by about 10 or so years. The 28nm node, a half-step node after the 32nm, probably first began shipping sometime in 2011, so it fits the pattern. The issue is getting from prototype to customer clean rooms in high volume. China has never been able to turn its prototypes into commercially competitive products. Something I've been wondering is why they put so much resources into prototyping this 28nm machine when they have hardly commercialized and sold any of the 90nm prototype machines from 10 years ago. Anyway, the goal now is to deliver commercial-ready 28nm ARFI machines in 2021 or 2022. So you get headlines saying that China quote-unquote will or quote-unquote confirm to have such machines by 2021 or 2022. But it seems likely to miss this deadline. Beijing Guowang, the critical optics supplier, is working on a foundry to build SMEE's optical systems. But Equal Ocean points out that construction on said foundry is not expected to be completed until September 2023. Considering the lag of integration and all, a 2024 ship date might be ambitious. And even then, the product is not expected to be commercially competitive. Kind of like with press release announcements of some revolutionary battery technology that recharges in 5 seconds, microwaves or dinner, and never leaves the laboratory, Chinese news sources tend to blow up the headlines. Here's one such example. In November 2018, the Institute of Optoelectronics Technology at the Chinese Academy of Sciences announced that they created a 22nm quote, super resolution end quote lithography tool. CCTV announced that with multi-patterning, a special technique, process nodes below the 10nm level can be achievable. But the devil is in the details. As it turns out, the tool is not even close to being commercially ready. The accuracy is low, and the tool's field of view is just a few square millimeters, which means it will take forever to crawl across and finish just one wafer layer. By contrast, ASML's TwinScan NXT1970Ci, a comparable DUV machine capable of the 38nm node and below, offers a field of view of 858 square millimeters, 26 by 33. This is a shipping product, capable of doing over 250 wafers an hour. I feel like this one is a significant issue. We hear a lot of stories about Chinese companies offering outrageous sums to some engineer to come work for them, but that does not seem to be the case for SMEE and ASML. Per Chinese job info sites, entry-level college graduates make about 45,000 USD a year, though I have also seen much lower figures. PhDs on average make about twice as much. SMEE's average PhD salary is about the same as ASML's company-wide average salary. Glassdoor notes that at the higher end, some staff software engineers make nearly 200,000 USD a year. Imagine what an optics PhD might make. Even considering the difference between Shanghai and the Netherlands, there is a significant pay gap. SMEE eventually going public someday might help even out this gap a little, but not significantly. We have also not yet discussed the very real job benefits and working atmosphere associated with working at a Dutch company. Share purchase plan, pension plan, commuting allowance, 40 days of paid leave, 8% holiday allowance, and so on. It will be challenging for SMEE to be as generous in their benefits, holidays, commute, housing, or otherwise. The company has nowhere near ASML's capital base, Europe's most valuable tech company at $300 billion, or even that of a Canon or Nikon. Rather, SMEE is one of China's national champions and bears expectations on par with CATL or Huawei. Thus, the company has adopted Huawei's working practices. This means long working hours, considerable political intervention, tough annual assessments for bonuses, and a Jack Welch-style bottom 5 to 10% layoff each year. This is based on comments from Chinese message boards and job sites. Human capital is the lifeblood of the semiconductor manufacturing industry. It's one of those industries where the right person can bring immense value to a company's competitive edge, and is not like high-precision optics and mechanics PhDs grow on trees. I feel there is a significant gap between how the two companies work and treat their employees. ASML spends a lot of time and effort thinking about the best ways to develop their people and reduce turnover. SMEE's Huawei-inspired approach, on the other hand, is likely to lead to a hard time acquiring and retaining the same type and level of talent. SMEE's efforts get a lot of ink in the Chinese press. They refer to the photolithography effort as the Mount Everest of the intelligent manufacturing industry. As is the case with any such high-profile effort, there is a lot of steadfast cheerleading and rah-rah optimism. Here's one commonly encountered example. As an ancient civilization with history of 5,000 years, China has countless wisdom and strengths. Judging from China's 4 great inventions, 2 bombs and 1 satellite, aerospace manned spacecraft, space station, and many other scientific and technological achievements, there is nothing that can't be done by us Chinese. Strong rhetoric, and yes, sure, anything can happen. But so far, the reality is that SMEE is at least 20 years behind ASML in bringing a commercial-ready, upper-class lithography device to the market. Immersion lithography is just nascent, and EUV is even farther away. This is a reality that even Chinese sources readily acknowledge. Such rah-rah words and outrageous claims are counterproductive. It leaves behind pessimism when deadlines are inevitably missed and prevents people from facing the actual problem in front of them. On the other hand, I also don't want to say that China's semiconductor production equipment ecosystem is dead on arrival. For instance, the progress in back-end lithography and LED lithography is heartening, especially as China gains market share in the display industry. Furthermore, a few Chinese companies have managed to build a strong track record in certain semiconductor equipment areas. One has even managed to acquire TSMC as a client. We can go over them in the future. Anyway, one final thing on SMEE. I'm seeing that the company is considering an IPO sometime in the future, at valuations I reckon to be in the $5 to $10 billion range, but no official confirmation yet. Assuming they do that, they would release a lot of new information in their prospectus, and I can do an update if that happens. Alright, thanks for watching. That's it for tonight. If you enjoyed the video, consider subscribing. I would like to reach 100,000 subscribers someday. Remember to hit up the email newsletter and sign up, or check out the Patreon if you want to support the work and watch any of the early access videos. Want to send me an email? Drop me a line at john@asianometry.com. I love reading your emails. Introduce yourself, suggest a topic, or more. Until next time, I'll see you guys later.